Thank you for joining us as we introduce Streivor's cutting-edge demand control kitchen ventilation system, known as DemandAire. Designed to elevate performance and kitchen efficiency. DemandAire controls can be added to Type 1 hood systems, with associated UL 300 listed fire suppression systems, to facilitate the sequence of operation required by the mechanical, electrical, and fire suppression codes. DemandAire systems are pre-engineered to connect to hood accessories such as the hood's exhaust fan, supply fan, internal hood fans, hood lights, temperature switches, hood system switches, building management systems, and also the fire suppression system accessories, such as the electrical switches, alarm system, shunt trip breakers, electric gas valves, and reset relay. There are two hood system statuses: active, when the exhaust fan is powered, and inactive, when the exhaust fan is not powered, that can be present when the fire suppression system activates. If the hood system status is active when the fire suppression system activates, the DemandAire panel will continue to power the exhaust fan circuit and shunt power to the supply fan, internal hood fans, hood light circuits, and the electrical gas valve circuit if applicable. Supply power to the electrical shunt trip breaker to initiate shunting of electrical circuits in the fire suppression system's hazard zone and the alarm signaling circuit. If the hood system status is inactive when the fire suppression system activates, the DemandAire panel will power the exhaust fan circuit and continue to shunt power to the supply fan, internal hood fans, hood light circuits, and the electrical gas valve circuit if applicable. Supply power to the electrical shunt trip breaker circuit to initiate shunting of electrical circuits in the fire suppression system's hazard zone and the alarm signaling circuit. This video will consist of Streivor's DemandAire Electrical Control Panel, ECP. The ECP is a UL 508A listed hood system control panel for commercial kitchen ventilation hoods. The ECP houses electrical terminals to provide electrical connections to the hood system accessories, such as the exhaust hood's lighting, internal hood fans, if included, auto start temperature switches, the exhaust and supply fans, and the hood's fire suppression system. Consider these safety advisories when performing tasks on a hood system and the DemandAire ECP. All work on an ECP should be performed by qualified contractors. Ensure that all power from the source to the ECP is shut off, locked out, and tagged out. Verify that the serial number on the ECP matches with the serial number from the wiring diagram or drawing. Confirm that the power's voltage, wire's amperage capacity, and wire insulation are in accordance with the fan motor's nameplate. Reference the Streivor DemandAire ECP drawing, labeled DA, to obtain installation details from the hood schedule, electrical schedule, and electrical rough-in schedule. Identify the location and mounting method that were specified for the ECP by reviewing the drawing's design plan. If your ECP is hood-mounted, it will be pre-wired at the factory to its accompanying hood electrical accessories. For ECPs mounted remotely on a wall, the electrical wiring should be connected to its accompanying hood. Follow the ECP detail from the DemandAire drawing to determine if the ECP needs to be surface-mounted or recessed into the wall, along with the proposed height that it should be installed at. Keep in mind that 36 inch of access clearance is always needed in front of the ECP. The ECP may not come with manual switches if the project was designed to have those switches located elsewhere. The design plan conveniently shows the location of the applicable items, and the rough-in requirements section determines how electrical wiring should be brought to the ECP. Now that you have an overview of the system, proceed to the electrical control panel's wiring diagram for details on inputs and outputs that the accessories should be connected to. Take a moment to identify the connections and the terminal blocks associated with each accessory. For additional clarity, each connection is labeled with the required electrical voltage on the DemandAire drawing. To supply power to the electrical control panel (ECP), start by verifying that the circuit breaker voltage, phase, and amperage powering the ECP matches the requirements shown on the ECP drawings and the label located inside the ECP. After verifying the circuit breaker is the correct voltage, phase, and amperage, proceed to connect the 120 VAC single-phase power to the designated terminal blocks in the control panel. If this ECP includes motor starters, follow the steps in the motor starter installation section. If not, skip ahead to the next section. The input and output terminals on the motor starters will have been pre-wired by Streivor to the appropriate terminal blocks within the ECP. Verify that the circuit breaker voltage, phase, and amperage for each motor circuit matches the requirements of the motor starter and the ECP drawing. Verify that each overload has been set to 125% of the full load amps displayed on the corresponding motor nameplate. The overload setting can be adjusted as needed by rotating the dial to the desired amperage value. After verifying that the circuit breaker voltage, phase, and amperage is correct, connect the input power to the input power terminal blocks, as indicated in the ECP drawings. Proceed to connect the output power terminal blocks for each motor to the corresponding fan motor, again referencing the ECP drawings for the correct placement. For ECPs that don't include motor starters, connect the start-stop fan control signal terminal blocks in the control panel to the designated external destination, such as the motor starters or building management system, BMS. Locate your fan and light terminal blocks. The fan and light terminal blocks are 120-volt single-phase, 12-amp max capacity. Wire terminal block 1 in the ECP to the line terminal on the hood fan switch. Wire terminal block 2 in the ECP to the load terminal on the hood fan switch. And ground out the green wire. Wire terminal block 9 in the ECP to the line terminal on the hood light switch. Wire terminal block 10 in the ECP to the load terminal on the hood light switch. And ground out the green wire. To supply power to the hood lights, wire terminal block 11, hot, terminal block 12, neutral, and ground to the corresponding wires in the junction box labeled E1 on the hood. If the light switch is controlling the hood lights on multiple hoods, locate the E1 junction boxes for each additional hood and daisy chain them together. The ECP is engineered to comply with NFPA 96, Section 10.4.1. If the fire suppression system is provided by Streivor, the ECP will provide terminal blocks with 120 VAC single-phase power to be connected to a normally closed dry contact interlocked with the FSS activation to be provided as part of the FSS. The ECP will provide the electrical functionality for the fire suppression accessories such as normally open 120 VAC signal for electrical shunting, etc. When the fire suppression system is activated, the ECP will shunt power to the hood lights, internal hood fans, and the supply fan run signal contact. The ECP will close the exhaust fan run signal contact and apply 120 VAC power to the normally open shunt terminals. The manual reset relay provided as part of the FSS will shunt power to any electric gas shutoff valves. Streivor's fire suppression systems will include 3 electrical switches and 1 alarm switch, sometimes referred to as microswitches. The electrical switch is rated for 250 VAC single-pole double-throw switch that facilitates turning on or off devices that are required during the system activation. The alarm switch is rated for 28 VDC and includes screw lugs to be used to close a supervised circuit connected to the building's fire alarm system. To wire Locate an FSS electrical switch located in the FSS control head. Wire terminal block 70 to the common leg of the FSS electrical switch. Wire terminal block 71 to the normally open leg of the FSS electrical switch. Wire terminal block 72 to the normally closed leg of the FSS electrical switch. Terminal block 71 can be used to provide power to a shunt trip device to comply with NFPA 96 Section 10.4.1. Terminal block 71 should provide 120 VAC power upon fire suppression system activation. The building alarm circuit is to be connected to the alarm switch with lugs. If the fire suppression system is not provided by Streivor, the ECP will provide terminal blocks with 120 VAC single-phase power, to be connected to a normally closed dry contact interlocked with the FSS activation, to be provided as part of the FSS. The ECP will not provide the electrical functionality for the fire suppression accessories, such as the gas shutoff valves, reset relays, shunt trip signals to the breakers, etc. When the fire suppression system is activated, the ECP will shunt power to the hood lights, internal hood fans, and the supply fan run signal contact. The run signal contact for the exhaust fan will close. To supply power to your internal hood fan, IHF, if applicable. Wire terminal block 3, hot. Terminal block 4, neutral. And ground in the control panel, to the wires in the junction box labeled E2 on the hood. If the ECP is controlling the IHF on multiple hoods, locate the E2 junction boxes for each additional hood and daisy chain them together. Internal hood fan power to terminal blocks 3 and 4 will be automatically shunt during a fire suppression system activation to comply with NFPA 96 Section 8.3.2. To supply power to the auto start temperature sensors. Wire terminal block 7, hot. Terminal block 8, load. And ground in the control panel, to the wires in the junction box labeled TJ on the hood. If the ECP is controlling the temperature switches on multiple hoods, locate the E3 junction boxes for each additional hood, and daisy chain them together. Before troubleshooting, test any ground and neutral shorts. Verify that the control panel has 120 VAC power, and verify you have power going out. If your fans are not turning on and your ECP includes motor starters, check the yellow indicator on the motor starter and reset the overload if applicable. Verify if the overload is set to the correct amperage indicated on the project's as-built hood drawings. Check that the fan switch wiring is connected and that there is continuity between terminals 1 and 2, while the fan switch is activated. If not, see switch schematic to verify the switch is wired correctly. If your fans are not turning on and your ECP does not include motor starters, check the fan motor power from the circuit breaker and the other components between the breaker and the fan motor. Contact the respective manufacturers of the components of the fan motor power circuit for troubleshooting those items. If your hood lights or internal hood fans are not turning on, check the FSS cabinet to verify its control head is in the armed position. Check that the hood light switch wiring is connected and that there is continuity between terminals 9 and 10, while the hood light switch is activated. Check that the fan switch wiring is connected and that there is continuity between terminals 1 and 2, while the fan switch is activated. If there is not continuity, see switch schematic to verify the switch is wired correctly. Check outgoing power to the internal hood fans in terminals 3 and 4, or 11 and 12 for hood lights. Check that the FSS electrical switch is wired correctly. Check that there is continuity between terminal 70 and 72. Check that there is not continuity between terminal 70 and 71. For projects with multiple hoods, check the interconnecting wiring between the hoods at the pre-wired junction boxes on top of the hoods. If the hood lights or internal hood fans are receiving power, and they are still not operable, replace the inoperable item. If your exhaust fan does not turn off, verify that the FSS control head is in the armed position. Check that the fan switch wiring is connected and that there is continuity between terminals 1 and 2, while the fan switch is activated. If there is not continuity, see switch schematic to verify the switch is wired correctly. Check that the FSS electrical switch is wired correctly. Check that there is continuity between terminal 70 and 72. Check that there is not continuity between terminal 70 and 71. Verify that the auto start temperature switches ASTS are set to the desired temperature set point. If you need to adjust your temperature switches, start by removing the access enclosure cover plate. Remove the protective cover and rotate the dial to your desired set point. For additional details, refer to our installing and commissioning auto start temperature switches video. If the issue persists, check for an alternate source of power and contact the respective manufacturers of the components of the fan motor power circuit for troubleshooting those items.
At Streivor Air Systems, we consider customer service and quality assurance a top priority. For any additional support, please email our team at info@streivor.com, and thank you for helping Streivor strive for excellence.